Today's lesson is to determine the theoretical probability of an event and convert between probabilities and odds. When the outcomes in a sample space of an experiment have the same chance of occurring, the outcomes are said to be equally likely. On the left, the spinner has equally likely outcomes. There's the same chance the spinner will land on any of the colors. On the right, the spinner has not equally likely outcomes. There's a greater chance the spinner will land on blue than on any other color. The theoretical probability of an event is the ratio of the number of ways the event can occur to the total number of equally likely outcomes. So theoretical probability equals number of ways the event can occur over, or divided by, the total number of equally likely outcomes. An experiment in which all outcomes are equally likely is said to be fair. You can usually assume that experiments involving coins and number cubes are fair. An experiment consists of rolling a number cube. Find the theoretical probability of each outcome. Rolling a 5. The number of ways the event can occur is 1. There is 1 5 on a number cube. Over the total number of equally likely outcomes is 6. There are 6 different numbers on the cube. When you divide 1 by 6, you get 0.1666666, and so on. When you change that to a percent, you move the decimal place 2 places to the right, and you get 16.66666%, or 0.666 equals 2/3. So 16 2/3%. An experiment consists of rolling a number cube. Find the theoretical probability of each outcome, rolling an odd number. The number of ways the event can occur is 3. There are 3 odd numbers on the cube. Over the total number of equally likely outcomes, there are 6 different numbers on the cube. If you reduce 3 6, you get 1/2, and if you divide, you get 0.5. Changing that to a percent, you move over the decimal 2 places to the right, and you get 50%. An experiment consists of rolling a number cube. Find the theoretical probability of each outcome, rolling a number less than 3. The number of ways the event can occur is 2. There are 2 numbers less than 3 on the number cube, 1 and 2. Over the total number of equally likely outcomes, 6. 6 different numbers on the cube. If you reduce 2 6, you get 1/3. If you divide 1/3, you get 0.33333, and so on. Making that into a percent, you move the decimal place 2 places to the right, and you get 33.333333%, or 33 1/3%. An experiment consists of rolling a number on a number cube. Find the theoretical probability of each outcome. You have A and B to do on your own, and then you can check back for your answer. Rolling an even number for A, the number of ways the event can occur is 3. There are 3 even numbers on the cube. Over the total number of equally likely outcomes is 6. Reducing that number, you get 1/2. If you divide 1/2, 1 divided by 2, you get 0.5, and changing that into a percent, you move it over 2 places to the right, and you get 50%. For B, rolling a multiple of 3, the number of ways that the event can occur is 2. There are 2 multiples of 3, 3 and 6. On the number cube. Over the total number of equally likely outcomes, there are 6 different numbers. Reducing to 6, you get 1/3. If you divide 1 by 3, you get 0.333333, so on. Changing that into a percent, you move it 2 places to the right, and you get 33.3333%, or 33 1/3%. The probability of an event can be written as P, and then in parentheses, what the event is. So let's say we're flipping a coin, and we want to know the probability of heads. So we'd say P of heads, P parentheses heads. That means the probability that heads will be the outcome. When you toss a coin, there are 2 possible outcomes, heads or tails. The table below shows the theoretical probability and experimental result of tossing a coin 10 times. The experimental probability ended up being that when it was tossed 10 times, 3 out of 10 times it was heads, 7 out of 10 times it was tails. So if we combine them together, the 3 heads and the 7 tails, we would get 10 out of 10 tosses, and that equals 1 when it's reduced. The theoretical probability of heads would be 5 out of 10, which reduces to 1/2, and tails would be 5 out of 10, which reduces to 1/2 as well. And 1/2 plus 1/2 is 2/2, which also reduces to 1. The sum of the probability of heads and the probability of tails is 1, or 100%. That is because it is certain that one of the two outcomes will always occur, either heads or tails. The probability of the event happening plus the probability of the event not happening will always equal 1. The complement of an event is all the outcomes in the sample space that are not included in the event. The sum of the probabilities of an event and its complement is 1 or 100% because the event will either happen or not happen. So when you combine together how many times it happens versus how many times it not happened, it will always be 100% of what you ended up doing, rolling a die or flipping a coin. The probability of the event plus the probability of the complement of the event is always going to equal 1. A box contains only red, black, and white blocks. The probability of choosing a red block is 1/4. The probability of choosing a black block is 1/2. What is the probability of choosing a white block? Either it will be a white block or not. So the probability of red plus the probability of black plus the probability of white equals 100% of the blocks. So if we know that the probability is 1/4 for the red blocks, if you change that, divide it into a decimal and change it into a percent, it's going to be 25%. And you know that the black blocks are 1/2. So if you divide that and change it into a percent, that's 50%. So 25% for the red plus 50% for the black plus the probability of a white block equals 100%. So we have 75% plus the probability of a white block equaling 100%. Subtract 75% from both sides, and we end up with the probability of drawing a white block as 25%. A jar has green, blue, purple, and white marbles. The probability of choosing a green marble is 0.2. The probability of choosing blue is 0.3. The probability of choosing purple is 0.1. What is the probability of choosing white? This one's for you to try on your own, and then you can check back for your answer. So either it will be a white marble or not. So we have the probability of green plus the probability of blue plus the probability of purple plus the probability of white equaling 1. So if the green was 0.2 plus the blue, which is 0.3, plus the purple, which is 0.1, plus the probability of white, which is what we're trying to figure out, it's going to equal 1. So we get 0.6 plus the probability of white equaling 1. We subtract 0.6 from both sides, and that gives us that the probability of drawing a white marble will be 0.4. Odds are another way to express the likelihood of an event. Odds express likelihood by comparing the numbers of ways an event can happen to the numbers of ways an event can fail to happen. The odds in favor of an event describe the likelihood the event will occur. The odds against an event describe the likelihood the event will not occur. Odds are usually written with a colon in the form of A colon B, but can also be written as A to B or A divided by or over B as a fraction form. Odds in favor of an event. Odds in favor would be the number of ways an event can happen over the number of ways an event can fail to happen, A to B. Odds against would be the number of ways an event can fail to happen to the number of ways an event can happen, B to A. A represents the number of ways the event can occur, and B would represent the number of ways the event would fail to occur. The two numbers given as the odds will add up to be the total number of possible outcomes. You can use this relationship to convert between odds and probabilities. You may see an outcome called favorable. This does not mean the outcome is good or bad. A favorable outcome is the outcome you are looking for in the probability experiment. The probability of rolling a 2 on a number cube is 1 to 6. What are the odds of rolling a 2? The probability of rolling a 2 is 1 to 6. There are 5 unfavorable outcomes and 1 favorable outcome. Thus, the odds are 1 favorable outcome to 5 unfavorable outcomes. Odds are the number of ways the event can happen to the number of ways the event can fail to happen. So it would be 1/5. Odds in favor are 1 to 5. The odds in favor of winning a contest are 1 to 9. What is the probability of winning the contest? The odds in favor of winning are 1 to 9. So the odds against are 9 to 1. This means there is 1 favorable outcome and 9 unfavorable outcomes for a total of 10 possible outcomes. So the number of ways the event can happen to the total possible outcomes for probability is 1 to 10. The probability of winning the contest is 1 out of 10. The odds against a spinner landing on red are 2 to 3. What is the probability of the spinner landing on red? The odds against landing on red are 2 to 3, so the odds in favor would be 3 to 2. This means there are 3 favorable outcomes and 2 unfavorable outcomes for a total of 5 possible outcomes. So for probability, it's the number of ways the event can happen to the total possible outcomes. So we would have 3 out of 5. The probability of landing on red is 3 out of 5. The odds in favor of winning a free drink are 1 to 24. What is the probability of winning a free drink? This one's for you to try on your own, and then you can check back for your answer. The odds in favor of winning are 1 to 24, so the odds against are 24 to 1. This means there's 1 favorable outcome and 24 unfavorable outcomes for a total of 25 possible outcomes. So for probability, it's the number of ways the event can happen over the total possible outcomes. So it would be 1 out of 25. The probability of winning the drink is 1 out of 25.